So in this video, we're going to take on the topic of sampling distributions. And we've been kind of building up to this topic for quite a while. In this unit, we're going to take on this in an abstract way, but in order to try to make sense of this, I'm going to give a very concrete example. Okay, so we have things that are called statistics and parameters. Okay, statistics are measurements of samples that align with measurements of a population. So things that we could measure. We could measure the mean of a sample. We could measure the proportion of a sample that has a particular characteristic. We could measure the standard deviation of a sample. Sorry, that's not that. It's standard deviation of a sample. That's S. And these are, so you notice that there's like an X bar for the mean, P hat for the proportion, little s for the sample, the standard deviation. When you move that over to the population, you take the mean of the sample, which is mu, the proportion of the sample that has a particular characteristic, which is P, no hat, or the standard deviation of the sample, sigma, of the population. So these are all of the population itself. This is where inferential statistics happens. Inferential statistics is we use incomplete data to talk about the population. So a sample is incomplete information to talk about the entire population. So we believe that we can use these things to estimate these. So these are going to estimate these. Okay, so what's going to happen in the notes there is it's going to talk about the variability of a sample. So you get variability. So you can take samples of size little n from this population, big N, right? And you can take a number of them, and let's say the very specific example I give here is like I take the sample of size n and then I take the mean of that sample, right? Well, if I do that once, I'm going to get a number. If I do that a second time, I'll get a second number, right? Third time, I'll get a third number. So I've just taken 3 samples of the same size from the same population, and I got 3 different numbers. So these are likely to be different. Now, what I do know about them, though, is that they form a distribution. So if I do this many, many times, they're going to form some sort of distribution. And they're going to be centered around some number, and they're going to be spread within a certain standard deviation, and all of this kind of stuff. Okay? Now, what I want to have happen is I would love to have the center of that distribution to be the thing that I'm trying to estimate. So I'd love to have the center of the sample means to be the population mean. I'd love to have the center of the sample proportions to be the population proportion. I'd love to have the center of the sample standard deviations to be the population standard deviation. So, spoiler alert here, it works for this one and this one being the center of that one and that one, but not this one. Okay, so it's not going to work when I do it with the standard deviation. Now, when I get that nice effect where the center of the distribution of the sample statistics is equal to the parameter, so this is the center of the distribution of the sample statistics is equal to the parameter, we get to call that thing an unbiased estimator. And those are good ones, right? Because it actually makes the math of inferencing estimator. Makes the math of inferencing very simple, because this distribution is going to happen to be a normal distribution or sometimes something called a t-distribution. We'll get into that later. And you can use some things like your empirical rule and things like that to draw inferences pretty simply. So this is the best of all possible worlds here. So what do we have? We take statistics, which are measurements of samples. We're going to use those to make estimates as to what we think the population's parameters are going to be. So we learn about the population by only taking a small sample of it, and then try to figure out how close to the actual number I can be, or I can guarantee myself to be. Okay? So this is a quick introduction to what are sampling distributions, and the next several units in this course we're going to dress this up. So we're going to dress it up about like sample distributions for proportions, and sample distributions for means, and then we'll even look at sample distributions for slopes. Okay, and things like that. We get into another distribution that's called chi-squared, which is a goodness of fit kind of thing that you guys used in bio and things like that. So, all right. So this is a quick, easy introduction to sampling distributions. This will be what we're taking on the next couple days in class. Thank you.